Hello everyone, this is the first video on Unit 5 Influential Statistics. In this video, we discuss about confidence interval. In particular, we understand confidence interval of the population mean mu. Okay, to understand the definition of confidence interval, let us discuss or let us recollect few things what we discussed in the previous unit. Let me consider the population of size n. Now we know that population is nothing but totality of observations, and characteristic that describes the population are mean, variance, sigma square, and proportions. Let me denote this by p. Now these are called parameters, and if the population size is very large, and it's difficult to find this mean, variance, and proportions, or sometimes it's practically impossible. In that case, what we do here is we consider samples or different samples from this population. If this is one particular sample of size n, and we can easily find, since the sample size is small enough, we can easily find mean, variance, and proportion from the sample. Suppose x bar is mean, and variance is s square, and proportion is p cap, then we can say that x bar, s square, and p cap are very good estimate to the population parameter mu sigma square p. But x bar is not exactly equal to mu. Now in this unit, what we do here is, since we cannot exactly find mu, but we can find an interval within which this mu lies, and we can say with some percentage of confidence that mu lie in this particular interval. Okay, that's the reason that interval estimate is also called confidence interval. Okay, that is, suppose if we could able to find E such that mu lie between x bar minus E and x bar plus E, then this E is called maximum error of estimate, and this interval is called interval estimate, and this is also called confidence interval. Okay, let me explain why it is called confidence interval. And the task is to find this E, and we know that this small x bar is nothing but one value in this random variable x bar. This is nothing but random sample. This is one of the value, and what we do here is, if suppose this happens, if the probability that mu lie between x bar minus E and x bar plus E is 1 minus alpha, then and this interval is called A is called 100 1 minus alpha percentage confidence interval. Now why? Because with 100 1 minus alpha percentage confidence, I can say that mu lie between these 2 points. Okay, now we need to find E such that this happens. Okay, now how do we find this? And for this, we consider different cases. The first case is this: we assume that sigma square is known, that is, variance is known. We're trying to estimate or we are trying to find the confidence interval for mean, population mean, assuming that variance is known, and sample size is sufficiently large, or population is normally distributed. If this is the case, then we can standardize this random variable x bar as this: z is equal to x bar minus mu divided by sigma divided by root n, where mu is population mean, which is same as mean of sampling distribution of means, and sigma divided by root n is nothing but sigma x bar, that is standard deviation of sampling distribution of means. Okay, once we standardize this, okay, you keep this. I'll be using this in next step. Look at this diagram now. Okay, for instance, This diagram I consider 2 points, z alpha minus 2 alpha by 2 and minus z alpha divided by 2, and we see that the area between these 2 points is 1 minus alpha, and this area is alpha by 2 and this area is alpha by 2, and this point is called a critical point. Okay, later I'll tell why this is called critical point. Anyhow, for instance, for this moment, let us consider this as z alpha by 2, that is area covered after this point is alpha by 2, something like this. Okay, if this is the case, now I substitute for z. This is true, right? This is true. Now I substitute for z. We know that z is x bar minus mu divided by sigma divided by root n, and do some manipulation. What I get here is this. You can see this. I substituted for z, and the second step I rearranged it. Okay, I keeping this mu in between these two numbers or these two random variables. Look at this. What we are trying to find is this. We're trying to find E such that the probability that mu lie between these two is 1 minus alpha, and it found that E, and that E is this. This is E. Thus, this interval is x bar minus z alpha by 2 sigma divided by root n, x bar plus z alpha by 2 sigma by root n, and this is called 100 1 minus alpha percentage confidence interval for population mean mu. That is for any sample mean x bar with 100 1 minus alpha percentage confidence, we can say that mu lie between these two numbers. Okay, this is confidence interval provided that sigma square is known, n is sufficiently large, or population is normally distributed. If neither of this is true, then I cannot say that z, this is I cannot consider this. Okay, next in particular, if alpha is equal to 0.05, we call this 95% confidence interval. That with 95% confidence, we can say that mu lie between the two numbers, whatever I stated earlier. If alpha is equal to 0.01, then we have 99% confidence interval. But if the percentage of confidence increases, the length of the interval also increases. You can observe this. Okay. Sometimes 99% confidence interval is of no use because the interval length will be so huge that it may not be used in solving problems or analyzing something. If alpha is equal to 0.05 and z alpha by 2 is nothing but 1.96, if alpha is equal to 0.01, then z alpha by 2 will be approximately 2.58. Thus, 95% confidence interval is this: x bar minus 1.96 sigma divided by root n, and x bar plus 1.96 sigma divided by root n, and 99% confidence interval is this. Okay, it's worth to remember these numbers 1.96 and 2.5, because frequently we may ask questions on 95% confidence interval, 99% confidence interval. If not, you can look into that table. Okay, let me take one example. This is one particular example. Read this question. The average zinc concentration recovered from a sample of measurement taken is 36. Okay, taken in 36 different locations in a river is found to be 2.6 grams per milliliter. That is average zinc concentration. They're saying that sample size, and in this case is 36, and x bar is 2.6. And they given standard deviation as 0.3. Standard deviation of what? This is population standard deviation, and therefore standard deviation of x bar I don't find this because already in the formula there is a x sigma divided by root n. Once we have this population standard deviation, and 95% confidence interval is given by this x bar minus 1.96, right? just now I explained why this is so. Sigma divided by root n lesser than mu less than x bar plus 1.96 sigma divided by root n. You substitute for x bar, sigma and root n. X bar is 2.6 minus 1.96 and sigma is 0.3 divided by root n is 6. 2.6 plus 1.96 0.3 divided by 36 square root of 36. It's clear that this implies this number is okay, I can find that this number is 2.5 and this number is 2.7. That is, with 95% confidence we can say that the population mean lie between 2.5 and 2.7. Look at this, what information we have here is sample mean from the sample of size 36 and standard deviation which is 0.3. From this we could able to find that mean, that is population mean, always lie between 2.5 and 2.7 with 95% confidence. That's quite interesting, right? Similarly, to find 99% confidence interval, in place of 1.96 we need to put 2.58, I guess. Yeah, and you can see that the length of the interval increases, but confidence also increases in that case. Okay, and that's it. We can also define one-sided confidence interval. That is, in this case we have upper bounds as well as lower bound. This is a lower bound for this mean, population mean, and this is upper bound for the population mean. In most of the problem we may be interested or sometimes need to find only upper bounds or lower bounds. In this case this is upper bound for this population mean, and lower bound is minus infinity, and this is a lower bound for the population mean, and upper bound is infinity. This is under 1 minus alpha percentage confidence. Since we are interested in one upper or lower bound, this area must be, as you can see the picture here, this is upper bound, this area must be alpha, the whole area must be alpha minus 1 minus alpha. If that is the case, and this value is not 1.96 for 95% confidence interval, it will change. You can say that because the whole area is 1 minus alpha, that is 95 percentage, that is 0.95, and find the corresponding value of z, okay, in the distribution table, and this may change. Okay, and that's it. In next class or next video, what we do is we discuss confidence interval when sigma square is unknown or n is small enough. In that case, we cannot approximate x to a standard normal random variable. In that case, we have to define something called t distribution. We'll look into that.